Okay, so let me repeat it. We are looking at temperature dependency of rate equation. R is a function of temperature and composition, and temperature dependence is represented by rate constant K. Minus R is equal to K C to the power of N, and K is equal to K naught e to the power minus E by RT. Right? K naught is frequency factor or exponential factor. E is activation energy. Take two temperatures T1 and T2. We can write the rate equation. R1 is equal to K1 Ca to the power of N. R2 is equal to K2 Ca to the power of N. K1 is equal to K naught e minus E by RT1, and K2 is equal to K naught e minus E by RT2. We divide, or we can write in logarithms this equation 1 and 2. That ln R1 is equal to ln of K1 into K to the power of N. Ln of R2 is equal to ln of K2 into K to the power of N. Divide 4 by 3, get ln R2 by R1, ln K2 K to the power of N divided by K1 power of N. K to the power of N gets cancelled out. What we get is ln K2 by K1, which is nothing but ln K0 e is minus E by RT2 on K0 e is power minus RT1. K0 cancel once, and what you get is ln of E is power minus E by R bracket 1 upon T2 minus 1 upon 1. Now we can take the minus sign inside. We get ln of E raised to the power of R, E by R bracket 1 upon T1 minus 1 upon T2. This we can write as ln of R2 by R1 ln of K2 by K1 equal to E by R minus 1 upon T2. Any questions on question 5? पुराना ये किया हुआ है आपको केमिस्ट्री में, but we need to consider here also. No more questions. We can proceed now. The rule of thumb is rate equation or rate of reaction doubles for every 10 degrees centigrade rise in temperature. We have a reaction at 10 degrees centigrade, and same reaction is carried out at 20 degrees centigrade. That's 10 degrees centigrade. So rate of reaction at 20 degrees centigrade double that at 10 degrees. The rule of thumb. ऐसा नहीं exactly 10 होगा. Rule of thumb is just like a rough approximation. You can say. We plot ln k versus 1 by t. This equation 5. ln k versus 1 by t plot किया तो क्या मिलेगा? You'll get a straight line.
सर वॉइस बहुत कम आ रहा है.
हाँ?
वॉइस बहुत कम आ रहा है सर.
वॉइस बहुत कम आ रहा है. प्रॉब्लम है क्या? सबको कम आ रहा है कि किसी को आ रहा है?
अभी क्लियर है सर.
अभी क्लियर है. ओके, सो आई वाज सिटिंग टचिंग माय बैक रेस्ट ऑफ द सीट, सो आई विल नॉट टच इट. सो सीधा नहीं बैठूंगा मैं, टेढ़ा ही बैठना पड़ेगा. तो ऐसा आई एम नियर टू द माइक्रोफोन, थोड़ा डिस्टेंस है माइक्रोफोन से, इसीलिए शायद नहीं आ रहा था आवाज. तो इफ यू प्लॉट, लेट्स सी कहाँ है क्वेश्चन. Yeah, if you plot this equation, if you take ln of this equation, let me put it. If I take ln of this one, ठीक है, बराबर है. If I take the log of both the sides, I'll get ln of k is equal to ln of k naught minus E by RT. ठीक है. If I plot this one, that means I'm plotting ln k on the y-axis and 1 by t on the x-axis. इसको मैंने अलग कर दिया. So if I plot ln k versus 1 by t, right? So what I will get is intercept is equal to ln k naught and slope is equal to minus e by r. और generally 1 by ये होता ही है because t is into Kelvin. तो जनरली 10⁻³ -3 इंटू +3 हो जाएगा इस साइड आएंगे तो ठीक है. So if you know at least two values of k at different temperatures, you can plot ln k versus 1 by t and find what is the value of k naught and minus e by rt or e. ठीक है. And this is an experiment in your CRE practical where you need to find the value of k naught and e. ठीक है. So what is activation energy? आप लोगों ने पढ़ा है केमिस्ट्री में कहीं? पढ़ा है कि नहीं पढ़ा है केमिस्ट्री में एक्टिवेशन एनर्जी?
हाँ सर.
So what is it? What does it represent?
Sir, it is the minimum amount of energy required to occur the reaction.
Yes, correct. So if the activation energy is more, what does it mean?
Means reaction is too slow.
Okay. ठीक है. So let us see what it is. The activation energy is essentially if you plot energy of reacting molecules on the y-axis versus reaction progress on the x-axis. So you get this kind of curve, and this is the energy of reactants, and this is for the products. And it has to go through a barrier. This kind of barrier is there, and what is this? This value is actually activation energy on the y-axis. So it has to reach that value to become activated or form a transition state, and then only the reaction can occur and the product can be formed. And if the curve is like this, where the energy of reactants is less than that of products, then this delta between products average energy and reactor sector average energy is called delta HR, rate of reaction. And here it is positive because it is product minus reactant. Right? And when delta HR is positive, it is endothermic reaction. What does endothermic reaction mean?
Heat is absorbed.
Heat is absorbed. That means we have to supply heat for the reaction to take place. Heating करना पड़ेगा इस reaction में. So externally we have to supply heat through some source. It could be heating through steam or some diatherm like heating medium. Some heating medium has to be there to sustain the reaction if it is endothermic. And if it is like this, where the energy of reactants is more than that of products, then delta HR is negative because again it is equal to energy of products minus energy of reactants. So it is negative, and it is exothermic reaction. So what does exothermic reaction mean? क्या मतलब exothermic reaction का?
Heat is evolved.
It is evolved. That means we have to cool. That means in the exothermic reaction we have to continuously remove the heat of reaction by cooling Cooling could be through water, it could be some through chilled water, or it could be some refrigerating system. But we have to remove the heat to sustain the reaction. That is why we will look at heat of reaction, I think in unit 4 or 5, how it is affecting reaction. Okay? Any questions on activation energy? Okay, so let's proceed further. No reactions or no questions. So what is the significance of activation energy? So reacting molecules must acquire minimum energy before products are formed. That's what you said, right? उतना वो energy barrier cross करना था before it can react. The reactants pass through activated state before they react. The energy required by reactants to overcome activated state or energy barrier is activation energy. Right? So temperature dependence we have seen. Plot ln k versus 1 by t, you get a straight line. So if the slope is large, हमने देखा था, right? If the slope is large, then A is more. If the slope is small, then E is small. And reactions high energy of activation are very temperature sensitive. What does temperature sensitive mean?
मतलब सर थोड़ा सा टेम्परेचर चेंज करने के बाद बड़ा
Right.
चेंज आएगा.
Because that exponential, right? E raised to power minus E by RT. If the value of E is high, then if you change the temperature, few degrees, you see significant effect on K. And if the value of E is low, then it is temperature insensitive. इतना फर्क नहीं पड़ता है. And then temperature is much more sensitive at low temperature than at high temperature. We'll see that. So if you look at this plot, ln k versus 1 by t, and there are two temperatures, T2 and T1. In this case, T1 और T2 का relation क्या है? Which one is bigger, which one is smaller?
T2 is bigger.
T2 is bigger. Why?
Because sir 1 upon Tn reaction.
Right.
Sorry.
T1 is smaller and T2 is bigger. Right? Because you are taking 1 upon T. Okay? So if you plot these slopes, in this slope we have activation energy. किसमें ज़्यादा है किसमें कम है? You have plotted two. एक ये है लाइन और एक ही लाइन है, राइट? ग्रीन लाइन एंड रेड लाइन. तो एक्टिवेशन एनर्जी किसमें ज़्यादा है किसमें कम है?
रेड में ज्यादा है और ग्रीन में कम.
क्यों?
स्लोप ज्यादा है ना.
राइट, बिकॉज यू लुक एट स्लोप, राइट? स्लोप इसका कम है, इसका कम है और इसका ज़्यादा है, एंगल ज़्यादा है, राइट? सो दिस इज हायर and this is lower comparatively, right? E2 is higher and E1 is lower. बराबर है?
नो सर,
तो
E1 हायर आएगा ना, E1 का स्लोप ज्यादा है ना.
ओके, तो E1 is higher बोलते हैं, ठीक है. I want to see कितने सो रहे हैं. Okay, so E2 is higher and E1 is higher and E2 is slower. बराबर? Lower, sorry, slower है, lower. करेक्ट है क्या अभी?
Yes sir.
यस सर.
स्लोप इज सिमिलरली सेम थिंग, राइट? ये लोअर है इसलिए लोअर है ये. Barabar. So now if I take two temperatures T1 and T2 and see what is the effect of change in temperature. Suppose T1 is less, T2 is more, right? So I suppose I increase the temperature from T1 to T2. What happens to K? कहाँ पर ज़्यादा इफेक्ट आ रहा है K का? Where is the change in K more?
T1.
Right. Why is it higher? You get drawn this thing, right? एक टेम्परेचर का लाइन ड्रॉ किया है कांस्टेंट वर्टिकल यहाँ पे, राइट? यहाँ पर एक पॉइंट आया, यहाँ पर एक पॉइंट है, राइट? सो रेड लाइन का जो है इतना K डिफरेंस है, राइट? इस डेल्टा, राइट? सो दिस इज डिफरेंस इन डेल्टा और ln K का डिफरेंस में, और यहाँ पर जो है दिस इज द डेल्टा डिफरेंस फॉर द ग्रीन लाइन. So K is more affected or changed by temperature in this case than in this case. ठीक है? Is it clear? ये हायर रहेगा तो K ज़्यादा बढ़ेगा, K ज़्यादा चेंज होगा, और ये लोअर रहेगा तो K कम चेंज होगा. Any questions? ठीक है. If there are no questions, let us proceed to the next one. तो अभी आपने केमिस्ट्री में पढ़ा होगा ना, कोलिजन थ्योरी, ट्रांजिशन स्टेट थ्योरी, पढ़ा है कि नहीं? Yes, no, don't remember, don't know.
Yes, sir.
पढ़ा है ना? What is collision theory and what is transition state theory? Briefly, डिटेल नहीं चाहिए मेरे को. Just one sentence, 2 sentences. किसी को याद नहीं है?
सर कोलिजन थ्योरी बोलती है कि अगर दो मॉलिक्यूल्स में कोलिजन होगा तो ही रिएक्शन होगा.
Right. So it is essentially proportional to the rate of collisions, right? Reaction is always proportional to the rate of collisions. बराबर? And so if the molecules are very far from each other, the collision likelihood is very less. If they are closer to each other, then collision likelihood is more. बराबर है? So collision theory and transition state theory, generally equation comes in this form: K equal to K naught prime, temperature raised to the power of m, e raised to minus e by RT, where m is between 0 to 1. So exponential term is more temperature sensitive than pre-exponential term. ये जो term है, because exponential है, ये ज़्यादा sensitive है, whereas this term is not so sensitive.
सर
Yeah.
सर वो एक्टिवेशन एनर्जी लेकर हम रिएक्शन स्लो है या फास्ट है वो नहीं बता सकते क्या?
एक्टिवेशन एनर्जी या बता सकते हैं, क्यों नहीं बता सकते? वही बोला ना, इट्स ऑल कंपैरिजन ना. कंपैरेटिवली कौन सा ज़्यादा स्लो है, कौन सा कम है. You'll see in I think यूनिट 3 में या 4 में आएगा, वेयर एक्टिवेशन एनर्जी कैसे क्या, बट इसेंशियली वही है कि जिसका एक्टिवेशन एनर्जी कम रहेगा वो जल्दी ज़्यादा रिएक्ट होगा जब फास्ट, जिसका एक्टिवेशन एनर्जी ज़्यादा रहेगा वो ज़्यादा स्लो होगा.
यस सर.
So the variation of the exponential term is effectively masked by exponential term. ये जो term है K naught is not so sensitive, whereas exponential term, because it is exponential, it is very sensitive. So it's very, Arrhenius law is very good approximation of temperature dependency for both collision state and transition state theories. Essentially, Arrhenius law and this, you can say that बराबर मैच होता है. I think यूनिट 3 में कहीं पर collision state theory या transition state theory है, देखेंगे हम टाइम मिला तो we'll go through that. But right now just understand कि Arrhenius equation or Arrhenius law and collision state and transition state theory almost give the same equation or temperature dependency. ठीक है? Any questions? Okay, questions नहीं है तो then we'll proceed further. This completes your unit 1, but there are many problems we'll solve. सिर्फ इससे नहीं होता because CRE is more about problems. We'll solve many problems. अच्छा, बुक में कुछ एग्जांपल दिए हैं, एक दो एग्जांपल मैकेनिज्म के, वो पढ़ लेना आप। ऐसा कुछ डिफिकल्ट नहीं है, उसमें से कुछ आता नहीं है, बट जस्ट फॉर अंडरस्टैंडिंग यू कैन रीड इट।
सर बुक कौन सा है?
लेवल स्पियन।
ओके।
Okay, so can you see this?
Yes, sir.
Okay, so for a gas reaction at 400 Kelvin, the rate is reported as minus dPa by dt is equal to 3.66 Pa square, and कॉमा के बाद एटमॉस्फेयर पर आवर दिया, दैट मीन्स यूनिट्स ऑफ रेट इक्वेशन दिया है। ए पार्ट इज व्हाट आर यूनिट्स ऑफ रेट कांस्टेंट निकालेगा है, and B part is what is the value of the rate constant for this reaction if the rate equation is expressed as minus Ra equal to minus 1 upon V dNA by dt K Ca square, and rate का units है moles per meter cube per second. So essentially this is nothing but conversion, units and conversion, जो हमने पीसी में भी किया था unit 1 में, right? So अपने you have to convert from one set of units to another set of units. कर सकते हैं क्या? Yeah, can you do it? यस नो कुछ तो बोलो।
हाँ सर, ट्राई कर।
I have taken this problem because this problem comes so frequently in the exam. या तो इनसे में आता है फाइनल में कब कहीं ना कहीं आ ही जाता है. Same problem. That's in almost every year. So first is, let's look at first part. What are units of rate constant? That means ये जो rate constant है, what is the value of the rate constant given here?
3.66.
Right. So ये rate constant है, इसका हमको units निकालने का है. Is that difficult?
Sir, per atmosphere per hour.
Per atmosphere per hour. कैसे निकाला?
yes sir, same.
कैसे
Sir,
निकाला?
3.66 pa square. मतलब 3.66 atmosphere square equals to atmosphere per hour. So 3.66 equals to atmosphere upon atmosphere hour, atmosphere square per hour. Atmosphere cancel 1 upon atmosphere into hour.
Okay. So essentially इसका units दिया है हमारे को atmosphere per hour, right? Left hand side का. This is what this means. यहाँ लिखते हैं that means unit is of rate of reaction equal to 3.66 into PA square. PA square means atmosphere रहेगा. ठीक है. So if I bring this here, what I'll get is units of 3.66. Right? दिख रहा है ये?
Yes sir.
समझ में आया? सिंपल है, कुछ नहीं, because this unit is for actually this term. But लिखता है ऐसे है, rate equation के बाद कॉमन डाल के units डालते हैं. That is equation, जो rate equation है, rate है, rate of say change of PA versus time. That's what it means, right? The rate of change of partial pressure of A with time is essentially atmosphere per hour. तो यूनिट से सब्स्टिट्यूट करने के बाद निकालने का है. इसके लिए 1 या 2 मार्क मिल जाते हैं आपको. ठीक है. तो लेट्स लुक एट बी पार्ट में. बी पार्ट में क्या है? दिस इज गिवन. नाउ वी नीड टू कन्वर्ट इट इनटू दिस फॉर्म. And units are given as moles per meter cube per second. That means ये जो यूनिट्स है ये एक्चुअली इसका है, right? And we need to find out what is the units of rate constant. इसका यूनिट्स क्या होगा? What are units of concentration?
Concentration inverse time mole per meter cube time inverse.
Mole per meter cube का square, right? Concentration is moles per meter cube, so it is moles per meter cube का whole square. इसका हमको पता नहीं है क्या होगा इसका यूनिट्स K का.
Meter cube per mole second.
Right. So essentially what we are doing is moles per meter cube second. इसका है यूनिट्स. K का हमको पता नहीं है. Ca square is nothing but moles per meter cube होल स्क्वायर, राइट। तो K का यूनिट्स हो जाएगा right. What you get is meter cube per mole per second, right. करेक्ट है क्या?
यस सर।
राइट। और पहले आपको बताया था मैंने यूनिट्स के का यूनिट्स जैसे जनरल ऑर्डर रिएक्शन बोला था, राइट। इफ यू लुक एट जनरल ऑर्डर रिएक्शन, सपोज nth ऑर्डर रिएक्शन, तो के का यूनिट्स क्या था बताया था ना मैंने आपको इक्वेशन।
कॉन्सेंट्रेशन इनवर्स इनटू टाइम इनवर्स।
नहीं, n के लिए सपोज n है, ऑर्डर ऑफ रिएक्शन इज n सपोज
1 minus n.
Concentration raised to 1 minus n and time raised to minus 1.
टाइम रेस्ट टू -1, राइट। टाइम रेस्ट टू -1 में सेकंड इनवर्स आ गया, कंसंट्रेशन रेस्ट टू 1 - n में यहाँ पर सेकंड ऑर्डर है, राइट। दिस सेकंड ऑर्डर, तो 1 - n which is meter cube per second, right. Essentially this is the same thing, concentration -1 seconds -1. ठीक है। Any questions so far? So now what we need to do is we need to essentially convert the units जो यहाँ दिया है, ये पीए में दिया है, इसको हम सीए में कन्वर्ट कर देंगे। कैसे कन्वर्ट करेंगे? What is the relation between PA and CA?
PA equals to CRT.
Right. So we have seen that before. Essentially, if you look at, if we take ideal gas, PV equal to nRT होता है, right? And if I take 1 mole to 1 RT, or doesn't matter, I can keep n only, doesn't matter क्या हो गया, let me erase this, doesn't matter. So what will happen is if I take n by V, I get P by RT. What is n by V? Moles per unit volume. This is concentration term. ठीक है। So in this case, when I want to write PA is equal to CA into RT हो जाएगा। Concentration is equal to P. If I want to write for CA, sorry, let me put it this way, then you can see. So if I want to write for A, CA is equal to partial pressure by RT लेना पड़ेगा। And what I'll get is PA is equal to CA into R into T. ठीक है। Any questions? So now you can substitute for PA in this equation and calculate what is the value of K.
Sir,
Yeah.
sir, what is general order reaction?
Order anything. N can be 1, 2, 3, anything. This is general equation, so it's a general order reaction, it's nth order reaction. Let's say nth order reaction. Let's not write general order, it is confusing. ठीक है, nth order reaction, that is what we can write. K is equal to concentration raised to the power of 1 minus n time inverse. Okay, Dikshita.
Sir, how did we get concentration raised to 1 minus n?
Okay, let's see now. Let's go back to basics now. How is rate equation defined? ठीक है, बराबर है rate equation.
Yes, sir.
Units of rate are always moles or moles per unit volume per unit time, right? यही है ना. If I take look at this one, this is 1 upon volume, ये DNA is moles and this is time. ठीक है, is this correct?
Yes, sir.
So K into CA to the power of n, right? CA is moles per unit volume to the power of n. So now if I want to find the units of K, what I'll do, I'll bring this here and find what is the units of K. ठीक है, दीक्षिता.
Yes, sir.
Units of K will be moles per unit volume raised to the power of 1 minus n. ये वहाँ से बना है, यहाँ से बना है, and time raised to the power of minus 1. This is okay? So this is a concentration raised to the power of 1 minus n and time raised to the power of minus 1. ठीक है, दीक्षिता.
Yes, sir. Got it.
So this is general equation for any rate constant, any order, 0 order, first order, second order, third order, जो भी रहेगा, you can use this. So now what we have to do is we have to convert this equation minus dPA by dt is equal to 3.66 PA square in terms of concentration. So what we'll do is we'll substitute for PA, right, in terms of CA, right, and put the values of temperature will be 400 Kelvin because PA is equal to CA into RT, and R का वैल्यू क्या रहेगा वो देख लेना आप consistent units के लिए, because units are important. And then when you substitute, you'll get equation in this term and the value of K also will come. कर सकते हैं कि नहीं कर सकते? ट्राई करो. समझ में आया क्या प्रॉब्लम?
Sir, 3.34 into 10 to the power minus 5 meter cube per mole second.
Okay, let's see what are you getting. क्या है इक्वेशन?
Sir, last answer. K equals to 3.34 into 10 to the power minus 5 meter cube per mole second.
K equal to
3.34 into 10 to the power minus 5
यूनिट्स क्या है K का?
meter cube per mole second.
सी एस स्क्वायर आएगा ना K यहाँ पर. बराबर ऐसे आया आपका. लेट
Yes, sir.
मी चेक क्या आंसर आ रहा है मेरा. बाकी लोग ट्राई करो. बराबर है 3.34 10 to the power minus 5. करेक्ट है. गुड. बाकी लोग भी ट्राई करो. अभी नहीं होता है तो घर पे करो. होमवर्क असाइनमेंट ये बहुत बार आता है एग्जाम में. इनसे फाइनल में भी आता है बहुत बार. इट्स अ सिंपल सब्स्टिट्यूशन और कुछ नहीं है. All you have to do is substitute for PA in terms of CA. Put the value of R and T. R का वैल्यू क्या लिया वैभव?
सर एटमॉस्फेयर में पूछा था ना तो 0.0821 बाय 1000 लिया. मोल में चाहिए था इसलिए
081
0.0821 बाय 1000.
okay. Actually 0.082 it is ठीक है. 1000 में कन्वर्ट करें. एटमॉस्फेयर लीटर पर मोल पर केल्विन ऐसा होता है. राइट. ये एक है आर का कांस्टेंट. 81 नहीं रहता, 82 रहता है जनरली. विल सी टुमारो और नेक्स्ट टाइम. ठीक है जी. लेकिन जो बाकी लोग ट्राई करो घर पे एंड सी इफ यू कैन गेट दिस.
सर आ रहा है सेम.
आ रहा सेम. गुड. क्या देवेंद्र तुम्हारा आया क्या?
हाँ सर आया सर.
ओके ठीक है. जिसका नहीं हुआ अभी तक घर पे करो. वेरी सिंपल सब्स्टिट्यूशन बट इट विल हेल्प यू फॉर द एग्जाम. बाद में एग्जाम और भी एग्जाम्पल करेंगे हम नेक्स्ट टाइम बिफोर वी एंड आवर यूनिट 1. ठीक है. So we'll stop recording.